In this video, we're going to talk about algebra. This will be a full review on algebra. We're going to talk about concepts such as simplifying, SURDS, indices, rationalizations, inequalities, quadratic functions, how you find the discriminant, simultaneous equations, and the like. So without wasting much of the time, let's start with the first concept of simplifying. So how do you simplify expressions? For example, if I'm given 4x minus 5y plus 3x plus 6y. So how do I solve such an expression? So I have to first solve the ones with the like terms together first. So I've got 4x and I've got 3x. I can solve these ones independently. Then I've got negative 5y and a 6y. So I'm going to replace them like that. So I have 4x plus 3x, then I have negative 5y plus 6y. Then from there I'm just supposed to solve. So 4x plus 3x, that will give me a 7x. Then negative 5y plus 6y, that will just give me a positive y. So basically this is how we simplify expressions. Let's solve another one. Let's say this time around I've got 3t plus 7s minus 5t, let's say plus 3s. So how can I solve this one? So there's a 3t here, there's a negative 5t. I'm supposed to solve those ones. I've got a 7s and a 3s. Okay, so let's solve. 3t minus 5t, what is that going to give me? It's going to give me a negative 2t. Then when I come to the other side, I've got positive 7s and positive 3s. They are adding, so I'm just going to have a 10s. So that's how we solve this one. Let's solve another one. Let's say I've got 4. I've got c plus 10d squared minus 2. I've got 2c plus d squared. So basically, how can I solve this one? I'm supposed to first expand. This 4 is going to multiply with everything that I have in the brackets. Okay, same with the other side. This negative 2 is going to multiply with everything that I have in the brackets. So let's start with a 4. The 4, when it multiplies with a c, I'm going to have a 4c plus, when the 4 multiplies with 10d squared, I'm going to have a 40d squared. When I come to the other side, the negative 2 multiplying with the 2c, I'm going to have negative 4c. The negative 2 multiplying with the d squared, I'm going to have a negative 2d squared. Then from there now, I'm supposed to now put the like terms together. I've got a 4c, I've got a negative 4c there. I've got a 40d squared and a negative 2d squared. Okay, so now 4c minus 4c plus 40d squared minus 2d squared. Now a 4c minus a 4c, that will just give us a 0, which I'm not going to write. Then I've got a 40d minus a 2d squared. Okay, so in this case, what is it going to give us? It's going to give us a 38d squared. So basically, this is the basic premise about simplifying. You're supposed to put the like terms together and solve them as they are supposed to be solved. So basically that. Then moving on to the next concept, indices. What are indices? Okay, these are powers. Okay, they are powers. You can also call them exponents or exponentials in simple terms. Okay, so an example that I can give is that, but before even start solving about, certain clear examples, indices have certain rules that you're supposed to follow, and it's very important that we talk about these rules as a start. So if I've got a, this a is to the power m, it is multiplying with a to the power, let's say, n. Now, according to the rule of indices, because we are multiplying and the bases are the same, here I've got a and here I've got a. So what you now do is that you are supposed to add your powers. Okay? So basically, that is according to the rule of multiplication of indices. So in this case, I'm going to have a, then I'm going to add my powers. I've got m plus n. So that is the first rule. According to the second rule, it's called the rule of divisions. If I've got a to the power m, then this is dividing with a to the power n. So how do I solve such a one? It is going to be a. However, according to the rule of divisions, you are going to subtract the powers. So in this case, it will be m minus n. Then let's say this time around, I've got a. This a is to a power. Then this a with the power, there is another power outside. So how do we solve such a one? So I'm going to write a. Then what I'm now going to do to the powers is that I'm going to multiply them. I'm going to have n to the power n. Okay. Another rule of indices that you're supposed to know is the rules of fractions. What if you have a power that is a fraction? A to the power 1 over m. Okay. How can you solve such a one? It is going to be the square root of a. Then you're going to put the m there. Initially it should be to the power 1. But to the power 1 won't even change anything. It will be the same expression. A good expression that I can put is when it is a to the power n over m. The way we can solve this one, the denominator becomes the root. So in this case, I'm going to have the root, okay, m, then there is a there. Then what I have as a numerator becomes the power, which is n, like that. So basically, these are the rules of indices. Now let's solve some questions. Let's say I've got y to the power 3 multiplied by y to the power 6. How do we solve such a one? Okay, so according to the rule of indices, what do we do to the powers? We're supposed to add them because we're multiplying. So it will be y 3 plus 6. Therefore, it will be y is equals to 3 plus 6. That will give us a 9. So basically, this is how we solve such a one. Let's solve another one. Let's say this time around I've got 4x to the power 2 multiplied by 4x to the power 4. Okay, so how do we solve such a one? First multiply the numbers, okay, then now move on to multiply the variables, okay. So in this case, I'm going to have a 4 multiplied by 4, that will give me a 16. Then when I come to the variable x squared multiplied by x squared, because we've got the same base, what am I going to do to the powers? Okay, so I'm going to add the power, so it will be x 2 plus a 4. This will further, give us 6x 2 plus 4, that will give us a 6. So basically, this is how we solve such a one. Let's solve another one. Let's say this time around I've got 9 to the power half. How can we solve such a one? We've said the denominator becomes the root. So in this case, I'm going to have the square root of 9 to the power 1. And the square root of 9, it is just a positive or a minus 3. So basically, this is how we solve this one. Let's solve another one with a fraction. Let's say I've got 64 to the power 1 over 3. How do we solve such a one? It's going to be what we have as a denominator to become the root. In this case, it will be the cube root of 64. Everything to the power 1. So I'm not going to put the 1 because it's not going to change much. Okay, so in this case, the cube root of 64, a number that we can multiply 3 times to give us 64. That is a 4. So basically, that is how we solve this one. However, what if we've got a negative power or a fraction with a negative? How can we do that? Let's say I've got 25 to the power negative 3 over 2. How do we solve such a one? So what happens is that the negative becomes a 1, okay, over the whole expression without a negative. So 25 3/2. Okay, now that I've got this, what I have down, I solve it the way we solve normal indices. So it will be 1 over the 2, the denominator 2, it's going to become the root. Okay, so in this case we're finding the square root of 25. Okay, then what we have as the numerator 3 becomes the power. So in this case I'm just going to have 1 over the square root of 25. What is it going to give me? Okay, it's going to give me positive or minus 5. Now what I have to the power 3, so I'm going to have 1 over it's either it can give me a positive or minus 5 to the power 3, that is like a 125. Okay, so basically that. So that's how we solve that one. So let's solve another one. Let's say this time around I've got 7x to the power 4. Then let's say I've got a 2 outside. How do I solve such a one? So the power is going to fall with everything that we have in the brackets. Okay, so in this case I'm going to have 7 squared, then x, I've got 4. This 4 is going to multiply with the 2. So I'm going to have 7 squared, that will give me a 49. X to the power 4 multiplied by 2, that will give me an 8. Okay, so basically that. Let's solve another one. Let's say this time around I've got 8y to the power, let's say negative 3. This is dividing by 2y to the power negative 7. So how am I going to solve this one? So since we're dividing, let me start first with the numbers. I've got 8 and 2. 8 divided by 2, that will give me a 4. Then now I come to the variables. I've got y. Now y is dividing, the base is the same, so what am I going to do to the powers? I've got a negative 3 and a negative 7. I'm supposed to subtract the powers. So this would be y. I'm going to write my negative 3 minus, there's a negative 7 on the other side. So we're going to have 4y, negative 3, then the negative and the negative, when they multiply, that will give us a positive 7. Therefore, I'm finally going to have 5y, negative 3 plus 7, that will give us a 4. So basically, this is how you solve indices. Moving on from indices, you are supposed to know how to expand. How you expand the expressions. Let's say I've got 6. Then let's say in the brackets I've got 3x plus a 2. How can I expand such an expression? So I'm supposed to distribute 6 and multiply it with everything that I have in the brackets. Now a 6 multiplied by a 3x, that will give us an 18x. The same 6 is going to multiply with the 2 on the other side. That will give us a positive 12. So this is an expanded form of the question that we have on top. Let's solve some questions. Let's say I've got x squared. This x squared is multiplying with 4 minus 2x to the power 3. How do we solve such a one? So the x squared is going to multiply with everything that is in the brackets. So x squared multiplied by 4, that will give us 4x squared. Then the x squared multiplied with the negative 2x to the power 3. Okay, so what are we going to have? We're going to have negative 2x. Now I've got a 2 and a 3, and they were multiplying. X and x squared and x cubed were multiplying. So you're supposed to add the powers. So I'm going to have x to the power 5. So basically, this is how we can solve such a one. Let's expand another expression. Let's say I have negative 2x, 5x minus 4. How do we solve such a one? So the negative 2x multiplied with the 5x, I'm going to have negative 10. Since the x are 2, I'm going to have x squared. Then the same negative 2x multiplied with the negative 4. I'm going to have positive 8x. So basically, this is how you expand this one. Let's solve another one. Let's say this time around I've got x. I've got 2x plus 3 minus 2, 2x plus a 1. So how am I solving these ones? I'm going to expand them independently. Then now I'm going to solve the whole expression. So when the x multiply with the 2x, I'm going to have 2x squared plus when the x multiply with the 3, I'm going to have 3x. When I come to the other side, negative 2 multiplied by the 2x, that will give us negative 4x. The same negative 2 multiplied with the positive 1 on the other side, I'm going to have a negative 2. Then, what did we initially say when we're starting? When you're simplifying, you're supposed to put the like terms together. In this case, they are already arranged. We have a 3x here and we have a 4x there. So we're supposed to solve to make sure that it fits like that. So in this case, I'm going to have 2x squared. Then 3x minus 4x, I'm going to have a negative x, then a minus 2. This becomes a quadratic. So we're going to solve quadratics as we move on. So basically, this is how you expand expressions. Let's make it a bit interesting. Let's say this time around I've got 3x squared. Let's say 2x plus 1 minus 5x squared. Let me put 3x minus 4. So how do we solve this type of equation? So likewise, the 3x squared is going to multiply with the 2x. So this case, this time around, I'm going to have 6x to the power 3 plus the 3x squared multiplied by the 1. I'm just going to have a 3x. I'm going to have 3x squared. Then negative 5x squared multiplied by 3x. I'm going to have negative 15x to the power 3. Then negative 5x squared multiplied by the negative 4 there. I'm going to have positive 20x squared. Okay, sounds interesting where we've reached now. So I'm supposed to now put the like terms together. So I've got 6x to the power 3. I've got negative 15x to the power 3. Then another expression is 3x squared and 20x squared. So let's solve these ones. So 6x squared minus 15 x to the power 3 actually. Not this. Okay, so 6x to the power 3. Then I've got plus 3x squared plus 20x squared. Then from here, what am I supposed to now do? I'm just supposed to solve. Okay, so I've got 6x to the power 3 minus 15x to the power 3. So I'm going to have negative 9x to the power 3. Then when I add the other ones, 3x squared and 20x squared, that will give me a 23x squared. So basically that's how we solve, by expansion. However, you can also be taught to factorize expressions. So how do we factorize? In this case, you're supposed to factorize them completely. So let's say we were taught to factorize this expression completely. Okay, minus 6x. This is a quadratic, but a simplified form actually. So when you're factorizing, get the common factor out, and whatever you remain with, put it in brackets. So in this case, I've got x this side and I've got x the other side. So because x is common, I'm going to put x outside. Then whatever remains, I'm going to put it, leave it in the brackets. So because we removed one x here, I'm going to remain with 1 here, minus 6. Basically, this is how we factorize expressions. Let's factorize some more. Let's say I've got 2x squared plus 20x. How can I factorize such an expression? So the 2 and the x are common on both sides. So what am I going to do? I'm going to factorize them out. So I'm going to have 2x. Then what remains, I'm going to put it in brackets. X plus the 2x divided into 20x. Okay, 2 divided into 20, that just gives us a 10. X and x, when they divide, that will just give us a 1. So basically this is the simplified factorized form. Okay, let's solve another one. Let's say this time around I've got x y to the power 2 minus x y. So how do I factorize such a one? Xy is common on both sides, so I'm going to remove the xy outside. Here I'm going to remain with 1y value minus on the other side I'm going to remain with okay, I'm not even going to remain with anything, just the 1 like that. So basically this is how we solve such an expression. Let's solve another one. Let's say I've got 6ab minus 2ab squared. Okay, so in this case what I'm going to do, we're going to factorize the 2ab. So 2ab, then I'm going to remain with what? Here I'm going to remain with a 3. When the 2ab divides into a 6ab, I'm going to have a 3 minus. Here I think I'm going to remain with a b, okay, because it's squared. So basically this is how we factorize, just normal expressions. However, you can also factorize quadratic expressions. So quadratic expressions have the form ax squared plus bx plus c. So where your a, your b and your c, these ones are constants, then your a should never be equals to 0. Okay, should never be equals to 0. So that is important about quadratic expressions. Let's solve some questions. So for quadratic expressions, okay, so for quadratic expressions, let's solve one. Let's say I've got 3x squared plus 9x. So we're going to factorize just the way we did the previous ones. So I'm going to have 3x being common. Here I'm going to remain with x plus a 3. Basically that's how we can factorize this kind of a one. But what if now we have 3 terms? Let's say this time I've got x squared minus 5x minus 6. So how do I solve such a one? I'm going to use the product, the sum, and the factor method. Okay, where the product is the multiplication of the coefficient of x squared and the constant, which is 6. So 1 multiplied by negative 6, it will give me a negative 6. Then the sum is the coefficient of b, which is negative 5. Therefore, we're going to look for two numbers. When we multiply them, they'll give us a negative 6. But when we add those same numbers, they'll give us a negative 5. So you'll be able to realize that 1 and negative 6 are able to achieve that. Okay? If we multiply these ones, they're going to give us a negative 6. But if we add them, we're going to have a negative 5. So basically, what we have there now is what we replace where the sum is there. Okay, so I'm going to have x squared minus 6x plus, instead of just writing 1x, I'm just going to write x. Okay, minus 6. Then what I'm now going to do is that I'm going to separate these two, I'm going to separate these 4 terms into 2 expressions. Okay, so and factorize them. So in this case, I'm going to factorize the x on the other side. I'm going to remain with x minus 6. When I come to the other side, since there's nothing that is common, I'm just going to put them in brackets like that. I can put a 1 if I want, or a plus 1 actually. So I'm going to put plus 1 x minus 6. Now you're able to see that this side I've got x minus 6 and x minus 6. I'm just going to pick one. Okay, x minus 6. Then what remains I'm going to put in brackets. I've remained with an x plus a 1. So I'm going to write my x plus 1. So basically this is how we factorize these kinds of expressions. Let's solve another one. Let's say I've got x squared minus 4. Okay, so how do we solve such a one? So we have a perfect square. So every time you have a perfect square, it's easy, you can convert it back to a square the way it was. So this would be x squared minus 4 is the same as 2 squared. Okay, so this will furthermore equate to the difference of two squares. So I'm going to have x minus 2 or x plus 2. So now I'm saying 4 is a perfect square because perfect squares, if you get numbers from 1 to 10, 1 to 9, okay, then you square them, the answers you're going to get are what we are calling perfect squares. Let's say I square these numbers. Whatever answer I'm going to get are what we are calling perfect squares. 1 squared is 1, 2 squared, that is a 4, okay, 3 squared, that is a 9, 4 squared, that is a 16, 5 squared, that is a 25, and a 36, and you're going like that. These are what we are calling your perfect squares. So you can return them back to squares like that. It's very important. Let's solve another one. Let's say I've got 4x squared minus 25. Okay, so 4 is a perfect square, 25 is also a perfect square. So I'm going to use the difference of two squares. So in this case I'm going to have 2 squared x squared minus 5 squared. Okay, then from there you're able to see that this is a difference of two squares. So in this case my final answer is going to be 2x minus 5, 2x minus plus 5. Basically that. Now never assume that this we've written is the same as if someone writes 4x squared plus 25. This is not the difference of two squares. So it's very important to also highlight on that one. Let's solve another question. Let's say this time around I've got x squared minus 8x plus 12. How do we solve such a one? I'm going to use our same product, sum and factor method. So in this case, the product, it is a 12. The sum, it is negative 8. Then the factors, two numbers that I can multiply to give us 12, but such numbers when they're added they'll give us negative 8. So negative 2 and negative 6 are able to achieve that. So I'm just now going to replace where the sum is. So I'm going to have x squared minus 2x minus 6x plus 12. Then I'm going to separate likewise, like we did in the previous sessions or in the previous examples. So in this case I'm going to factorize the x. Here I'm going to remain with x minus 2, then minus 6. On the other side I'm going to remain with x minus 2. Okay, so that when you multiply the 6 with the 6x with the x, it's going to give us negative 6x. When we multiply the same negative 6 with negative 2, it will give us a positive 12. Always your expressions should take you back to where you're coming from. So in this case, because the x minus 2 is common on both sides, I'm just going to get one of them. So this will be x minus 2 and x minus 6. Those will be our answers like that. So basically this is how we factorize expressions. Now we can also talk about what we call SURDS. For SURDS, these are a number under a root. Okay, now what you should understand about SURDS is that they give non-ending non-ending non-repeating decimal fractions. So basically, if I've got a square root of a prime number, in simple terms that will be a surd. Okay, why? Because mostly prime numbers are the ones that are going to give you answers that have non-repeating decimals. So what we mean is, if I get the square root of, let's say, and get the square root of 2, since 2 is a prime number, prime numbers are those numbers which only have two factors. Only one can go into that number and itself. So basically, if I get the square root of 2, it's going to give me an answer. Or since I don't have a calculator, but I can just illustrate 1 point, let's say 4, 2, 5, 6, 2, 1, 8, maybe 10. So this number is going to be going and it's never going to end. Okay, so basically those are what we're calling, non-repeating, like that. Those are surds, and you don't want a surd as a fraction or as a surd in your denominator. We're going to talk about rationalization of surds. Now there are rules to every mathematical concept. So if you have the square root of a and this a is multiplying by b, so what this is going to equate to is going to be, you can separate it as the square root of a multiplied by the square root of b. Another expression is if I've got the square root of, let's say I've got x over y, so this is going to equate as the square root of x over the square root of y. The last expression that I can put is, if I've got the square root of a, this is multiplying by the square root of a. What I'm just going to have is that initially you are supposed to, when you multiply it, it should take you back to that, right? Okay, it should take you to the square root of a multiplied by a under one root. Now a multiplied by a, that is a squared. So I'm going to have the square root of a squared. Now what is now going to happen is that the square and the root are going to cancel. Therefore, you're just going to remain with a. So the square root of a multiplied by the square root of a will just give you an a. That is a very important and powerful concept. Let's solve an example. Let's say I've got the square root of 20. This is dividing by 2. How do I solve such a one? I'm going to split my 20 into a perfect square. Okay, at least one number should be a perfect square. So there are two possibilities. I can multiply 2 multiplied by 10 to give us 20, or I can multiply 4 multiplied by 5 to give us a 20. But now looking at the first scenario, these numbers are not perfect squares, so it will be very hard for us to find the square root of such a number. But 4 has a perfect square, so we're going to go for the second scenario. So in this case, I'm going to have the square root of 4 multiplying by the square root of 5 over 2. Now the square root of 4, that is a 2, multiplied by the square root of 5, okay, over 2. Now if I multiply what I have on top, I'm going to have 2 root 5 over 2. The 2 and the 2 can divide, therefore I'm just going to remain with the square root of 5. That's how we solve the first one. Okay, let's solve another one. Let's say this time around I've got 5 to the square root of 6 minus 2 the square root of 24 plus, let's say, the square root of 294. Okay, so how do we solve such a one? So for this one, I'm going to maintain 5 root 6 minus 2. For 24, I can separate it into perfect squares. Okay, so there are two numbers that I can use: 8 multiplied by 3 or 6 multiplied by 4. Now 8 is not a perfect square, 3 is not a perfect square, so I'm going to go for the second scenario: 6 multiplied by 4, because 4 is a perfect square. So in this case, I'm going to have the square root of 6 multiplied by the square root of 4. Okay, plus, when I come to the other side, 294, if I multiply 6 multiplied by 49 to give me that. So I'm going to have the square root of 6 multiplied by the square root of 49. Then I solve. Okay, so now 5 root 6 is going to be maintained minus 2. Now a 2, there's a square root of 4 here, which is a 2. That 2 is going to multiply with this 2. That will give us a negative 4 root 6. When I come to the other side, the square root of 49, that is a 7. So I'm going to have 7 root 6. Now I'm able to see that we've got like terms. We've got all of them have got at least a root, and which is 6. And they've got numbers in front. So basically we're supposed to solve all of these ones. So we're going to have a 5 minus a 4. That will give us a 1. A 1 plus a 7. That will give us an 8. So we're going to have 8 root 6. So basically this is how we solve this one. Now you're supposed to know also how to rationalize the denominator of a surd. Okay, so if I've got a surd, let's say the square root of 1 over a. Okay, so this can be simplified as we've said. You can put the root on top for the numerator, and you can put the root down for the denominator. Now you don't want a surd as a denominator, because we said surds are non-terminating. Okay, so they continue like that. So if they are never ending, you don't want something that is never ending in the denominator, so you have to remove it. That's what we are calling rationalizing the denominator. So in this case, for you to do that, in this scenario, you're supposed to multiply the denominator and the numerator by the same root a. So in this case, I'm going to multiply by root a on both sides, on both the numerator and the denominator. Now when I multiply with what I have on top, a 1, the square root of 1, and the square root of a, I'm just going to remain with the square root of a. Then root a multiplied by root a, we said, just gives us an a. So basically this is how we rationalize the denominator. We've removed the surd from the denominator. So basically that. Then another scenario that you are supposed to know is, let's say I've got 1 over, let's say 2 plus, let's say root 2. So for this kind, you're supposed to multiply by the conjugate or the opposite of what you have as a denominator. So this is what we mean, 2 plus the root of 2. So we are going to multiply by the conjugate of what you have as a denominator. In this case, the conjugate will be 2 minus root 2. You're going to do that as well to the numerator. Then from there, I just solve. When the 1 multiplies with what we have on top, I'm just going to have 2 minus root 2. When I come down, this multiplied by that. Now they are the same, but they have different signs. So you're able to see that this is a difference of 2 squares. Okay. However, we're going to multiply them to see if we're going to get the same answer. So when the 2 multiplies with the 2, I'm going to have a 4. The same 2 multiplying with the negative root 2, I'm going to have negative 2 root 2. Then I come to the other side, the root 2 multiplied by 2, I'm going to have positive 2 root 2. Then root 2 multiplied by negative root 2. Okay, so we're going to have negative 2 because the roots are going to cancel. So basically this is what we have as for now. Allow me to rub the top part. Okay, what are we now going to have? I've got 2 root 2 on top. So I've got a 4 here. I'm going to write it. Then negative 2 root 2 positive 2 root 2. That will give us a 0. So I'm just going to remain with minus 2 on the other side. Then what do I now solve? I'm going to have 2 minus the root of 2 over 4 minus 2. That will give us a 2. Then can we simplify this one further? Yeah, if you want you can leave it there, but if you want you can simplify it further like that. Okay, but basically we've rationalized, we've removed the root from the denominator. So basically that's how we solve such kind, you know, of questions which we are calling SURDS. Now on this topic algebra, you also need to know what we call quadratic functions. Okay, now on each quadratic function you're supposed to know certain key things, how you can graph a quadratic function. This is major. Number 2, how you solve quadratic functions by factorization method, and we've done that. Okay, on quadratic functions you should know how you complete the square. Okay, complete the square. Then on quadratic functions you should know also how to solve using the formula method, okay, as opposed to the first two, factorization and completing the square. Basically on each graph that you are going to graph, these are just simple things that you're supposed to know. Okay, you're supposed to find the intercepts where your graph or your line is cutting the x and the y axis. Here we're talking about the x intercept and the y intercept. Then on each graph you're also supposed to know how to find the minimum and the maximum. These ones we call them the turning point, where your graph is also turning from. That is the same thing. Then for a graph you're also supposed to know the line of symmetry. The line of symmetry cuts the graph or your graph into two equal parts. Okay, so basically that. Now you can either use the table method or whichever method that you are very comfortable with solving quadratic or graphing them. Okay, so let's say I've got a scenario where I've got y is equals to x to the power 2 minus 3. So now how do we solve such a one? If I'm going to go for the table method, let's say this is my simple table. Okay, let's say here we're going to put numbers. Okay, I think those ones are enough. Let's say we've got x and y like that. Then we've got numbers here. Let's say I start from -2, -1, 0, 1. I can also put a 2. Okay, now what this means is that I'm going to be replacing in my equations on my equation. Then what I'm going to getting as the value of y, that's what I'm going to be writing down. So if I've got y is equals to, in this case let's start with -2. -2 squared, that will give us a 4, minus a 3. This will give us 4 minus 3, that is a 1. Okay, so I'm going to have a 1 here. If I have -1 squared minus 3, what am I going to have? That will give me 1 minus 3, that will give us a -2. If I've got a 0 here, 0 minus 3, that will just give us a -3 actually. -3. Okay, if I've got a 1 here, 1 squared minus 3, that is 1 minus 3, that will give us a -2. Then if I've got 2 here, 2 squared, that is 4, 4 minus 3, that is a 1. So basically that is what we have. Then we're supposed to graph this. We can graph that. So let's say this is our Cartesian plane or our x or y plane there. So how do we now graph this one? I can put numbers at least that I can just select. Let's say I've got this is -1, this is -2. On the other side, this is 1, this is 2. Let's say this is I can put -1, -2, -3. Then I can put 1, 2, okay, maybe even like 6. Now that I've got this, I can now plot my points. I've got -2, 1 as my first point. -2, 1 is going to be somewhere there. Okay, then I come to -1, negative 1 comma negative 2. Negative 1 comma negative 2 will be somewhere there. Okay, then I've got 0 comma 3. 0 comma 3 will be this same point. Then I've got 1 comma negative 2. 1 comma negative 2 will be somewhere there. Then I've got 2 comma 1. 2 comma 1 will be somewhere there. Then I'm just supposed to join these points. Nicely like that. That will be our graph. This we've drawn is what we are calling a parabola. Okay, so basically that. So it's very important that we understand that part of solving. Then we are supposed to also solve quadratic expressions, you know, using completing the square. Now when you're completing the square, let's say I've got x squared plus 12x. So in this case, what you're going to do is that you're going to half the coefficient of x. In this case, the half of 12, that will give us a 6. Then what you're now going to do is this to this one is you're going to add and subtract it. However, you're going to square it. So in this case, I'm going to have x squared. I can write plus 12x. Okay. Then I can write plus 6. This one I'm going to square it. Minus 6. This one I'm going to square it again. This expression, even if we solve it, is going to give us a 0. Okay. That's what it means. Now, since this expression has replaced this one, we are going to ignore the 12x. Okay, so I'm now going to have x squared plus 6 squared minus 6 squared. Then what I'm going to do is that these ones with the squares, I'm going to put them in one bracket. So I'm going to have x plus 6. This will be in brackets. Then I'll put a square outside. Minus. Now the 6 squared, that is 6 multiplied by 6, that will give us a 36. That is the answer that we are going to get. Now what does this answer tell us? There is a form that you always need to have. This form is you have our a outside over or open brackets. It can be x plus q, let me say x plus p squared minus q. That is a form that you always want to attain. Okay, so this is there, then the negative q is that. So basically that is a form that you always want to achieve. Okay, so let's solve another one. Let's say this time around you have got let's say 5x squared plus 20x. So how can you solve this one? I'm going to first because we said we want our form to be in a, x plus p squared minus q. So we want to make sure that the a is outside and x is an independent term there. So because we want x to be an independent term, I'm going to factorize out the 5. So 5, then x squared plus 5 into 20, that is a 10, then x. Okay, now that x is independent, we can now solve. So I'm going to have 5. Now to x squared, I'm going to have x squared here plus, I'm going to now find the half of 10x. So that would be 5 squared minus 5 squared. Okay, basically this. Then now I'm now going to now fully solve. So that would be 5. Okay, let me put big brackets here because I'm going to put x plus 5 in brackets. Okay, then minus 5 squared, that will give me 25. Okay, now what I'm now going to do is that now I'm going to distribute the 5 that is outside again back into the expression. So when the 5 multiplies with 1 here I'm just going to have a 5x plus 5 squared. When the same 5 now multiplies with a negative 25, or in this case it's actually going to divide, okay? So in this case, when it divides with the 25, what am I going to have? I'm going to have negative 5. So basically this will be our answer. Then we can also solve quadratic expressions using the quadratic formula. So now the quadratic formula is x is equals to negative b positive or minus the square root of the discriminant 4 squared minus 4ac over 2a. Okay, so now this is the quadratic expression that we have. So an example that we can solve on the quadratic, let's say we're told to solve x squared minus 3x minus 2 is equals to 0 by using the formula itself. So first we have to identify what a is, what b is, and what c is from our expression. Now a is 1, b is negative 3, c is negative 2. Then from there we just need to solve. So we're going to have x is equals to negative b positive or minus the square root of b squared minus 4ac everything, okay, everything over 2a. Now how are we going to solve negative? B is negative 3, so I'm going to put my negative 3 there. Okay, yeah, b is negative 3. I'm going to put my negative 3 there. Positive or minus the square root of b squared, that is negative 3 squared, then minus 4, our a is 1, over 2a. Okay, 2a over 2a, our a is 1. Then we solve. Negative and the negative here to just give me a positive 3. So I'm going to have 3 positive or minus the square root of, now negative 3 squared, that will give me a 9 minus 4. 9 minus 4, that gives me a 5. Okay, so I'm going to have a 5 here over 2. So therefore our final answers will now be x can either be 3 plus the square root of 5 divided by 2, or x can be 3 minus the square root of 5 divided by 2. So basically that is how we solve quadratic expressions. Then you can also be asked to solve quadratic expressions using the discriminant. Okay, now the discriminant is what you have in the root b squared minus 4ac. The discriminant tells us how the graph is going to behave, and that is very, very important for every quadratic expression. So let's say what happens when the discriminant b squared minus 4ac is greater than 0, meaning it's a positive number. What happens when b squared minus 4ac is less than, or let's say it is equals to 0? What happens when b squared minus 4ac is, let's say this time around, it is less than 0, it's a negative. So what we mean is that, in the quadratic we say x is equals to negative b positive or minus the square root of b squared minus 4ac over 2a. What we have in the root here determines how our answers are going to be. Okay, so that is what we are calling the discriminant. This that is in the root. Just imagine here, if you've got a negative number, how is your function going to behave in terms of the answers? Then just imagine there if you have a positive number or an answer which is equals to 0. That's what we're talking about. So in this case, when the discriminant is greater than 0, meaning when it's a positive number, you're going to have two different or what we call distinct real roots. Okay, but when it is equals to 0, it means you're only going to have one answer. Okay, one real root, or others are going to call them equal roots, because quadratic tends to give two answers. Okay, then for the last one, when the discriminant is less than 0, okay, you're going to have others are going to call them complex roots, because you have a big number. Okay, a complex number is a plus ib, where your I in this case is the image of a. Okay, these are big numbers, so basically you're going to have complex roots. Okay, so basically that. Now, how do these ones look? If we say the discriminant is greater than 0, okay, let's say this is our diagram. If, let's say, this was a quadratic and it was going like that, in this case, it means the quadratic or the discriminant is greater than 0. Let's say this is 0. Greater than 0 going this side, these are positive numbers. Less than 0 going this side, these are negative numbers. Now the scenario that we have now here is we have positive numbers, meaning the discriminant is greater than 0, right? So in this case, you're going to have two different answers. That's what we said. So in this case, you're going to have an answer there, x is equals to that and x is equals to that. This can be 2, maybe this can be 5. Okay, that's what we mean. Okay, the opposite is also true. Sometimes, depending on the graph that you have, this can also alternate on the other side. But as long as you have answers that are there, that is still correct. Okay, then when the discriminant, let's say this time around the discriminant is equals to 0. When the discriminant is on the middle itself, okay, just here, okay, in the root you have the square root of 0. You're just going to have 0 there. We are just going to have one answer. Okay, so this graph can come, however it's going to pass, but it's just going to touch at one point and go. So this can be maybe point number 2. It means at this point, that's where your graph is starting from. That is when it is equals to 0. Then when it's a complex number, it won't touch any value of x or y, or any value of x. It can be there, but it never touches any answer there, because you will not have any real root but complex roots. So basically that's what the discriminant does. It shows you the behavior of the whole function. So that is very, very important for us to know. So can we solve a question maybe using the discriminant? Let's say I've got x squared minus 5x plus 4. Okay, how can we solve this one? First, you can solve it using factor method or completing the square method. Those are the two methods that we've learned. So we're going to look for two numbers that when we multiply them, they'll give us 4, but when we add them, they'll give us negative 5. Okay, so I'm going to go for negative 4 and negative 1. So in this case, I'm going to have x squared minus 4x minus x plus 4. Then I factorize. I'm going to have x. Then I'm going to remain with x minus 4. Then I'm going to remain with minus. Okay, minus 1. Then I'm going to remain with x minus 4. Okay, then since x minus 4 is common, I'm just going to get 1. Then I'm going to remain with x minus 1. Okay, so basically that. So what will be our answers in this case? If I'm going to turn this one into an equation, I say it is equals to 0. What this means is that x minus 4 is equals to 0 and x minus 1 is equals to 0. Then I solve for the values of x. X will be equals to, when I take the negative 4 to the other side, it's going to become positive 4. When I go to the other side, x will be equals to 1. So what I have as answers, these are what we call critical values. This is where the graph is going to cut the x-axis, or what we call the intercepts of x. Okay. Now you can also find the intercepts of y. y will be equals to x squared minus 5x plus 4. Then on the y-intercept, x is equals to 0. So 0 minus 5, 0 plus 4. Okay, you're just going to realize that you're just going to get a 4. So meaning this graph is going to be cut at 0, 0,4 on the y, the y-axis. Okay, so basically that. Now you can now graph it if you want. Okay, maybe just draw a small one. Let's say this is our graph like that. This graph is going to pass through points like 4 for y. So if it's passing at 4, I'm going to put 4 there. If it's also passing at 1 for x, I can put 1 here. I can put 4 here. Okay. Therefore, this graph is also going to have a certain turning point. Okay. So in this case, let's say this graph comes, passes through 4, passes through 1. It's going to turn from somewhere and pass through 4. Okay. So basically, that is how our graph is going to look like. But now, the discriminant itself, you're able to see that if you're going to look at the values of b squared, and because the discriminant is b squared minus 4ac. If we're going to solve this, b squared, that is negative 5 squared, which will give us 25, minus 4, our a is 1, our c is 4. So it will be 25 minus 4 multiplied by 1 is 4, 4 multiplied by 4, that is 16. Okay, 25 minus 16, that is it like a 9? Yeah, something like a 9, something like that. Okay, but you're going to realize that it gives you a positive number. A positive number is greater than 0. So you're able to see that you're going to have two real solutions. So in this case, we've got a 1 and a 4. So basically that. So it is very important for us to solve and find these kinds of answers. Okay. Then on this topic, you also need to know how you solve simultaneous equations. So how do you solve simultaneous equations? You can solve simultaneous equations using elimination method. You can also solve simultaneous equations using substitution method. Then you can also later on solve using linear and quadratic inequalities later on, after we move on from simultaneous equations. So how do we solve using elimination? Let's say I've got 2x plus 3y. This is equals to an 8. Then I've got 3x minus y. Let's say this is equals to a 23. So how am I going to solve these quadratics? If I'm using elimination as a method, I'm going to look for a way to eliminate either x, either y or x. Okay, so in this case, what am I going to do? For me to eliminate, here I've got 3y, here I've got just the y. So I'm going to multiply the one that is down by 3, then the one that is on top by 1. So I'm going to have 2x plus 3y is equals to 8. When I multiply the 3 with what I have down, I'm going to have 3 multiplied by 3, that is 9x, minus 3y is equals to 23 multiplied by 3, 3 multiplied by 3 on that is 9, 3 multiplied by 2, that is 6. I'm going to have a 69. Then what I'm now going to do is that I'm going to now add 2x plus 9x. Okay, that gives me an 11x. Then 3y minus 3y, that will give me a 0. We've eliminated the y, is equals to then 8 plus 69. What am I going to have? 77. Okay, then I'm going to divide by 11 on both sides. My x therefore is going to be 77 divided by 11. That will give me a 7. So we found the value of x to be 7. It will be very easy for us to find the value of y. So we can just replace in any of the equations. So I can go for which one? The first one. So for the first one, I've got 2. X we found that is 7 plus 3y is equals to 8. 2 multiplied by 7, that is a 14, plus 3y is equals to 8. Okay, so I can I can take the 14 to the other side. I'm going to have 3y is equals to 8 minus 14. Okay, then 3y will be equals to 8 minus 14. That gives us negative 6. Then I divide by 3 on both sides. So y therefore be equals to negative 6 divided by 3. That will give us a negative 2. Okay, so basically that is how we solve quadratics using, elimination. Okay, now you can also solve quadratics using substitution as a method. So just even the name suggests you're trying to remove or substitute one of them. So instead of eliminating it, you're just substituting it. Okay, so let's say I've got 4x plus 2y is equals to negative 30. So how do we solve by substitution? Make sure that one of them is the subject of the formula. So I'm going to get the first expression because it's simpler. So I'm going to have 2x minus y is equals to 1. In this expression, I'm going to make y the subject of the formula. So I'm going to take the negative y to the other side. So I'm going to have, then I'm going to take the 1 to the other side. Okay, so I'm going to have 2x. When the 1 comes to the other side, it becomes negative 1. Or because when the y goes on the other side, it becomes y. So y therefore is equals to 2x minus 1. Okay, so this is the expression that we are now going to, since we've known the value of y, we are going to replace where there's 2y there, where there's y, we're going to replace by that expression. So I'm going to have 4x plus 2. Where there's y, we're going to place 2x minus y is equals to negative 30. Then from here, I'm going to have 4x plus the 2 is going to multiply with everything that I have in the brackets. Okay, excuse. 2 multiplied by 2x, that is 4x, minus 2 multiplied by 1, that is the 2 there, minus 30. Then from there, 4x plus 4x, that will give us an 8x is equals to negative 30. I'm going to take the negative 2 to the other side. It's going to become positive 2. Okay, then from here, I'm going to have 8x is equals to negative 30 plus 2, that is negative, what? Negative 28. Then I divide by 8 on both sides. Okay, therefore my x will be equals to negative 28 over 8. Okay, I can leave it there, it's still fine. I found my x to be negative 28 over 8. Okay, allow me to rub maybe this same part. We are just from solving. Okay, I found my x. Now I can replace to find y. Okay, in that expression. So to be y is equals to 2x minus 1. Y is equals to 2. 8x, we found that it is negative 28 over 8 minus 1. Then I just solve. 2 into 2, that is 1. 2 into 8, that is a 4. Okay, then a 4 into 28, is it a 7? Okay, that is negative 7 minus 1. Negative 7 minus 1, that gives us a negative 8. So basically that is how we solve such kind of an equation. Okay, then I remember during JETS we'll be asked questions to solve where you have one linear and one quadratic. So one is linear and the other one is quadratic. So usually substitution usually achieves it. Okay, substitution usually achieves it. Let's say we've got x, let's say we've got x plus 2y is equals to 3. This is a linear function. Then let's say down you've got x squared plus 3xy is equals to 10. So you're able to see that on top we have a linear, down we have a quadratic, but we're supposed to solve this simultaneous. So every time you're given such kind of a thing, just solve using the normal way you solve using substitution. So you're going to make x the subject. So in this case, I'm going to get the one that I have, x plus 2y is equals to 3. So I'm going to have x is equals to 3. When I take the 2y to the other side, I'm going to have negative 2y. So this is what I have as x. So I'm going to now replace this x into the quadratic that I have down. So I'm going to have 3 minus 2y, okay, minus 2y, it is squared, minus 3, again where there is x, I'm going to replace 3 minus 2y. Okay, then there is y, don't forget there is y outside, and then is equals to 10. Okay, basically that. So let's solve this first. So what am I going to have? I'm just supposed to solve the way we always solve. So this is a 2, then this that I have in the bracket. So the way you can simply solve this one simply, or in a simple way, the 2 is going to fall on 3, the 2 is also going to fall on 2y, then the 2 now is going to multiply with them. So let me start with what I'm talking about. When the 2 falls on 3, it's going to be 3 squared. Okay, minus, okay, the 2 is going to multiply with 2 multiplied by 3, that is a 6. A 6 multiplied by negative 2y, that would be negative 12y. Okay, then I'm going to put the last expression in we squared as well, like we did to the 3. That's how we solve that one in a simple way. Then we've got a negative 3 here multiplying with the y, so I'm going to have negative 3y. Then I'm going to have 3 minus 2y is equals to 10. Okay, then from here we just now solve 3 squared, that is a 9, minus 12y. Now this squared there, when we square these numbers, what are we going to get? Negative 2 squared in the brackets, that will be positive 4. Then we're going to have y squared. Okay, basically that. Then I'm supposed to distribute this part. So negative 3y, that would be negative 9y. The negative 3y multiplied by negative 2y, I'm going to have a positive 6y squared. This will be equals to 10. Then if there's anything that I can cancel and solve, I just need to solve it. So in this case, I've got y squared, 4y squared, and 6y squared, and 12y squared. Okay, so let's start with those ones. So negative 12, oh actually it's just these two. Okay, so it's just those two actually. Okay, so what do we now do? Okay, negative 3y, that is negative 9y, that is positive 6y squared. Okay, we are good, we are fine. So now from here, what I've got numbers. Okay, I can bring the 10 to the other side. I can bring the 10 to the other side. When it comes to the other side, it's going to be 9 minus 10. 9 minus 10, that will give us a negative 1. So I can put the negative 1 in advance. Then I've got a negative 12y and a negative 9y. What is it going to give me? Negative 12y plus 9y. That will give us negative 3y. Then to the others, I've got a 4y squared, and I've got a 6y squared. So these ones, I'm adding them. I'm going to have plus 10y squared. Okay, basically that is the quadratic that we have. Then we're just supposed to solve this quadratic, and the answers that we're going to get, that will be, let me put it here. So I don't have a calculator. Let's see if we can solve this one using completing the square. So let's say 10y squared minus 3y minus 1. Okay, can we even do this? Let's say the product, it is negative 10. The sum, it is negative 3. Factors. Two numbers, when we multiply them, they'll give us negative 10. But those two numbers, when we add them, they'll give us negative 3. So negative 5 and let's say 2. Can it achieve that? Yes. Okay. So meaning, now what would be our answers? So we're going to have 10y squared minus 5y plus 2y minus 1. Okay. Now if I solve this, I'm going to have, when I factorize this side, I'm going to have 5y. I'm going to remain with, here I'm going to remain with 2y minus 1. Okay. Then on the other side, I'm just going to remain with 1. Then 2y minus 1. Then from there, I'm just supposed to now pick, put them, those ones which are common. So I've got 5y plus 1. I'm going to put it in brackets. I've got 2y minus 1. Okay, I can put is equals to 0. Then from there, now I'm supposed to now find the values of x. Okay, so I'm going to now equate these ones to be equals to 0. So what that means is 5y plus 1 is equals to 0, and 2y minus 1 is equals to 0. Now when I solve these ones, what do I have? I've got a 5y is equals to, when the 1 goes to the other side, becomes negative. Then I divide by 5 on both sides. Okay, so in this case, I'm going to now have what? Y is equals to negative 1 over 5. Okay, then when I come to the other side, 2y is equals to 1. Then I divide by 2 on both sides. Okay, so our y is equals to half. Okay, so those are the two answers that we have for our y. So basically that, now what do we now do? Okay, that's where now we go back to what x is and just replace. Okay, so to find the values of x, just get your expression. So x is equals to 3 minus 2y. So one value of y, so this 3 minus 2, one value of y is negative 1 over 5. Okay, so that would be 3 minus, actually plus 2 over 5. Okay, then you can simplify that one further. Then you can also solve the other one, which is x will be equals to 3 minus 2. Our y is half. Okay, so the 2 and the 2 can divide, so therefore I'm going to remain as x will be equals to 3 minus 1, which will be x3 minus 1, that is a 2. That is another value of y. So basically those are some of the simple concepts that you can solve using this one. Substitution always tends to work. Okay, then you also need to know how you solve linear inequalities on this topic. Okay, so linear inequalities, an inequality, instead of equations, the ones were just from solving equations, but inequalities have got an inequality symbol. Let me say I've got 3x, let me say minus 1. This is less than 7. How do I solve this one? I'm supposed to put the like terms, so I'm going to have 3x, the linear inequality there, 7. Then when the negative 1 goes to the other side, it becomes a 1. So I'm going to have 3x is less than 7 plus 1, that is an 8. So when I divide by 3 on both sides, so x will be less than 8 over 3. Just the way we solve quadratic expressions, or that's the way we solve normal equations. Now here's where we need to be careful. For linear inequalities, every time you're dividing with a negative, you have to be very careful. You are changing the inequality symbol. Let's say I've got 4 minus 3x. This is less than 27. Okay, so how can I solve this one? I'm going to have negative 3x. This is less than 27. I'm going to take the 4 to the other side. It becomes negative. Then I'm going to have negative 3x. This is less than 27 minus 4. That will give me a 24. Is it? Or 23. That will give me a 23 actually. Yes. Then I'm going to divide by negative 3 on both sides. So because I'm dividing by negative 3 on both sides, every time I'm dividing by negative, my inequality symbol is going to change. So to be x will be greater than 23 over negative 3. Okay, basically that is how we solve such a one. You change the inequality symbol. So that is just the most important thing about you knowing that part of inequalities. Now, before I even talk about quadratic inequalities, sometimes you can be given, to find the set of values of x for which maybe two inequalities are true together. Okay, for example, they give you two sets of inequalities. Let's say they say 3x minus 5 is less than x plus 1, and the other one is, let's say, 5x, let's say it is greater than x minus 2. Okay, then they've asked you to find the set of values of x for which you are going to find the answers for these two. So the best way you can solve these ones, draw them on the number line, solve them the way they are, find the answers and draw them on the number line, so that you'll be able to see where they match. So let's start with the first one. So for this one, I'm going to have 3x. When the x goes to the other side, it becomes negative. So I'm going to have negative x is less than, I'm going to have 1. When the negative 5 goes to the other side, it becomes positive 5. Then from here, 3x minus x, that will give me a 2x. This is less than 1 plus 5, that is a 6. So when I divide by 2 on both sides, my x therefore is going to be less than 6 divided by 2, that is a 3. Okay, that is what I have on my left hand side. Let's come to the right hand side. When I solve the other one, it will be 5x. I'm going to take the x to the other side. It will be minus x is greater than negative 2. 5x minus 5x minus x, that will give us 4x. This is greater than negative 2. Then I'm supposed to divide by 4 on both sides. So my x therefore will be greater than negative 2 2 divided by 4, that is negative 1 over 2. Okay, so these are the two answers. So the region that you really need now is what you have on the mid. Okay, so for you to know better, I think a number line can do it very well. Let's say this is our number line, and from our number line I can draw the first one. X is less than 3. Okay, so x is less than 3. Let's say 3 is here. Okay, I'm going to put an open circle. Why? Because 3 is not included. We want those numbers that are less than 3. So we're going in this direction to the negative numbers. Okay, and then the other value of x, the other values of x are x is greater than negative half. Let's say negative half is somewhere here. Okay, the negatives are, then there's a 0 here. So x is greater than negative half. So I'm also going to put an open because negative half is not included. I'm going the other side. So you're going to realize that the answers that you want, they are where this where we have the common region on the middle there. So it means the range of values of x that we want, they are from -1 to -3. Okay, so in this case the range of values will be x. In this case let's write it on top. Okay, okay, so if we're going to write it on top, the lowest values of you are going to have negative half should be less than, it should be x should be greater than negative half, but x should be less than 3 because that's a region that you want. Okay, so you're always starting with the smallest number first. Okay, then you're going to the bigger number. That's how you write your solution. So basically that will be the solution that you are going to have. So that is how we solve these types of inequalities. Then sometimes you can also be asked to find what we call quadratic inequalities. So how do we solve quadratic inequalities? So let's say, for example, you are given a quadratic inequality, x squared minus 4x minus 5, this is less than 0. Then you are told to draw and sketch this. Now it's a quadratic inequality because you have a quadratic function and an inequality in there. That's what the expression means. Now what you can do is that every time you're solving a quadratic inequality, first solve the quadratic equation as if you're just solving any other quadratic equation. Then if you want, you can sketch the quadratic function. Then from there the graph is going to tell you the values, the set of values that you want. But another method is where you use the tabular method. Okay, so for example, let's start with the first one, this one. How do we solve just normal? So we are going to get this and solve it as if it's a quadratic equation. So I'm going to have x squared minus 4x minus 5, this is less than 0, but I'm going to solve it as an equation. I'm going to say it is equals to 0. Then I solve it. We're going to look for two numbers. When we multiply them, they'll give us -5, but when you add them, they'll give us -4. I think we've done this. -1 and -5 and 1. Okay, so I'm going to have x plus 1, x minus 5. This will be equals to 0. Okay, therefore now I'm going to have x plus 1 is equals to 0, x minus 5 is equals to 0. Therefore x will be equals to -1 and x will be equals to +1. So these are the values that we have for x. Now how do we now solve this? So if you're going to look at your graph, we don't even need to put everything on our graph. Only our answers are going to tell us. So if I've got -1 here and I've got 5 there, now our graph can either go like that or the opposite. It can go something like this. So now how do we know? We look at the value of a. Okay, so the value of a is the coefficient of x squared. When the coefficient of x squared is greater than 1, is greater than 0, you are going to have a minimum. Okay, when the coefficient of a is less than 0, you are going to have a maximum. So in this case we have the coefficient of x to be greater than 1, so in this case to be greater than 0, so it's going to be a minimum. So it can be a graph that looks like something like this. Now we don't even need to find the turning point. That is not our we just want to find the values which are of x, the set of values. So this value and that value. Okay, now what is the range? Is it these values of x that are going like that, or the ones on the middle, or everything? Okay, so we have to go back to the inequality. We look at the way the inequality is. The inequality is saying want the values where, you know, x squared minus 4x minus 5 is less than 0. Okay, is less than 0. So basically that. Now if we're going to pick any value of x that is, let's say, greater than let's say less than -1. Let's say I put that is greater than -1 or less than -1. If I get -2 and I put it in that equation, if I put -2 here, it will be 4 minus 8. That will give me, okay, let me just solve it. If I put -2 in the same equation, I'm going to have 4. Then I'm going to have plus 8. Then I'm going to have minus 5 is less than 0. Now 4 plus 8, that is 12 minus 5. That would be, we're talking about 12 minus 5, that is it an 8? Is it a 7? 7, yeah, 7. Now is 7 less than 0? Of course it's not. Okay, so 7 can't be less than 0. So it means this region going up is not one of our answers. Okay, because if you pick numbers that are there, they are not satisfying the inequality. So what if we pick any number between this region? Okay, let's say we pick a 0 and we put wherever there is x, we put a 0. So it will be 0 squared minus 4 multiplied by x, that is 0 minus 5 is less than 0. So if I say 0 minus 0 minus, I'm going to just have -5 is less than 0. Is -5 less than 0? Of course. So it means this region, there is a possibility that that's where we're going to get our answers. Okay, let's get now the regions where we have bigger numbers that are greater than 5. Okay, going this side. Let's say we pick a 6 and we put it in the equation. 6 squared, that would be 36, minus 6 multiplied by 4, that is a 24. Okay, minus 5. This should be less than 0. Okay, 36 minus 24, that will give us what? So 4, that is 6, that is like a 12, minus 5 is less than, that will also give us like a 7 is less than 0. A 7 can't be less than 0. So even this side, you were able to see that it's giving us wrong answers. Okay, so basically the region that you want is the one that is on the middle. Okay, this one. These are the values of x that satisfy this inequality. Okay, so basically that. So now what will be the solution? The solution set therefore now will be, you're getting from -1 is the smallest one, So x should be greater than -1, but x should be less than 5. Okay, basically that. So you follow the inequality. Okay, that's how the way it is. So basically that's how you solve using this kind of a method. Another method that you can use is a table method. Okay, so I'm going to keep the same question, but now let's solve it using the table method. So for the table method, let me draw a table. Okay. Okay, so there is our table. Then we have to put our equations and what we have as the critical points. So this is the first critical point, this is the second critical point. So I'm going to start with the smaller one. I can put -1 here. Okay, I can put 5 here. Then the equations that we have that gave us those answers, we had x plus 1 and x minus 5. Then what were they doing? They were multiplying here. So because they were multiplying, we're going to find the product on top, okay, of the signs. So these are going to act as a demarcation of signs. So basically now what we're going to now do is that the equation that gave us -1, it is x plus 1. Okay, so we're going to get a number that is less than -1 and try to put it there. Any number that is less than -1, let's say we put -2 and we put in x plus 1. I'm going to have, let's say -2. -2 plus 1 is going to give me -1, which is a negative answer. So at this region going below 1, I'm going to have negative numbers. What if I pick a number that is between -1 and 5? What sign is it going to give me? Let's say I pick a 0. A 0 plus a 1, that will give me a plus 1. A plus 1 is a positive number, so I'm going to put a plus there. What if I pick any number that is greater than 5? Let's say a 6. 6 plus 1, that is a 7. So I'm going to have a plus as well. Okay, now let's come to the next equation. X minus 5, it's the one that gave us a 5. Okay, so in this case, I'm going to write my x minus 5 there. X minus 5. Now we're going to pick any number that is less than 5 and put it in the equation. Let's say I pick even just a 0. Okay, if I put a 0, 0 minus 5 here, I'm going to have a negative number. So every time I pick any number that is less than 5, I'm going to be getting negatives. But if, let me try, I get a number that is greater than 5. Let's say this time around I get 6. Okay, a 6. 6 minus 5, that will give me a 1, which is positive. So is a positive. Then what I'm now going to do is that I'm going to multiply the signs, because we said we're finding the product of the equation. So negative multiplied by negative, that will give us a positive. The negative multiplied by a positive, that will give us a negative. Then a positive multiplied by a positive, that will give us a positive. Okay, now that we've solved that, we're going to go back to our inequality. Our inequality, we say want values of x that are, we're saying x, we want this expression when we solve, it should be less than 0. Okay, it should be less than 0. So in this case, we're talking about numbers that are less than 0 are negative numbers, right? So you don't want positive numbers. So because you don't want positive numbers, we're going to follow the negative region. Okay, so always be very very conversant with the inequality. So in this case, you're just getting values from here to there, here. Okay, if the inequality symbol was 1, if let's say, I'm just assuming, let's say in this case it was pointing the other direction, it means you're going to be getting numbers that are greater than 0. Numbers that are greater than 0 are positive numbers. So your region would have been from here going all the way to negative infinity, and from here going all the way to positive infinity, because that's where the positive numbers are. Okay, just to illustrate that point. So since here we want numbers that are less than 0, so in this case we're getting negative, the region which is negative. So in this case it is from negative 1 to 5. Okay, so basically how are you going to write it? Yes, the solution set. So in this case it's going to be negative 1. Yes, x should be greater than negative 1, but the same x should be less than 5. Okay, basically that, and you're able to see that it is the same as this one. So basically that's how you solve using the table method. Okay, so that's how you find the critical values, and that's how you find the set of values of x when you're given to solve for an inequality. Okay, so basically that. Now, of the most part, lastly on this topic, you're supposed to know how to solve exponentials and logarithms. Now this is one of the simplest topics. So on this one, you're supposed to first know how you graph equations. So we're talking about equations that are in the form of, an exponential. Let's say y is equals to, let's say, 2 to the power x, an exponent. We're talking about you graphing also logarithms. Okay, then also equations on this topic, very important. Okay. Then also changing the base. Okay, changing the base of the log, very, very important. So basically those are some of the concepts that you're supposed to understand. So let's start with exponentials. Okay, exponentials are what we just started with. So this topic just like concludes some basics on algebra. Okay, so we started with indices. Indices are just like the same as exponentials. So in this case, if I've got y is equals to, let's say, 2 to the power x, that is an exponent. Why? Because it's a number that has been raised to a power. So in this case, what I have as 2 is called the base. Okay, and then what I have as x there, that one is called the power or the index. So basically that is about exponentials. Now exponentials, the rules are almost the same as for indices. So for example, I can be given to solve, let's say, 2 to the power 0. Okay, any number to the power 0 is 1. Okay, even if I say 100 to the power 0, that will give me still a 1. Okay, so that is very important. But if I've got 2 to the power negative 3, because I've got a negative, you know that the negative becomes a 1, so I'm going to have 1 over 2 to the power 3. Now 2 to the power 3, so 1 over 2 to the power 3, 2 multiplied by 2 multiplied by 2, that gives us an 8. So that's how we solve this one. Then another simple thing that we can also talk about is how you can graph an exponent. Y, let's say y is equals to the same 2 to the power x. So if you want, you can come up with a table of values, but a graph, the way a graph of an exponent is going to look like, is going to come and pass and go like that. Now how does this graph come about? If let's say I come up with a table of values, x and y, x and y. So I look at the values of x and the values of y. Let's say I pick a negative 1, 0 and 1. If I put negative 1 here as a value of x, it will be 2 to the power negative 1, which will be 1 over 2. 1 over 2 is like 0.5, right? So if I say negative 1 is here for x, 0.5 for y, maybe somewhere here, 0.5, that's like half. Okay, that's why this graph is coming like that. Okay, the points are going to be moving in that direction and going like that. Then another point we can put is 0. If I put 0 here, 2 to the power 0, it is a 1. Okay, so if I've got a value of x as, if where x is 0, where x is 0 is on the y-axis. Okay, so 0 comma 2. Okay, so we're saying this is giving us 0.5, this is giving us 2 to the power 0, that is a 1, that is giving us a 1. Okay, so this point here is going to be a 1 because that's where it's passing at. Okay, then we can also put 1. What if x is 1? 2 to the power 1 is just a 2. Okay, so that would be a 2. So 1 comma 2, maybe a value of y which is 2 is somewhere there. It's going to be maybe a point somewhere here, 1 comma 2. So able to see that the graph is going in this direction. Okay, so that's how we graph exponentials. Now let me give you a clue here. You also look at the value of the function and the value of x. So the value of x here is positive. The value of the whole function is also positive. So the key thing here is that you are going to the values of y that are positive and the values of x that are positive. Where is y positive and where is x positive? So x is positive here, y is also positive here. When I come to the other quadrant, x is negative here, y is positive there. X and y, both of them, x and y, in this region they are negative. But when I come to the other side, x is positive, y is negative. So those are the basic principles that you're supposed to understand. So if, let's say for example, I say y is equals to 2 to the power negative x. So for this graph, I just have to make sure that, okay, we are going to the negative values of x, but the positive values of y. So in this case, it will be something like that. Okay, then automatically this one is going to be 1 because where x is equals to 0, if I put a 0 here, 0 to the power, there's nothing like negative 0. 2 to the power 0 is still a 1. It's going to be that point still. Okay, however, we're going to the negative values of x and also to the positive values of y. That's what this diagram is showing. Okay, so that is how you solve, you know, these kinds of graphs. Not very complicated. Then when we move on to logarithms, so you know, logs and exponentials, they usually go together. So if I've got 2 to the power 5, let's say it is equals to 32. Okay, the 5 from the exponential, this is what we are calling the logarithm. Then the 2 that we have there is what we are calling the base. Okay, then this is the answer. So if that is the case, so this can be written as, since we are saying the 5 is a logarithm, okay, it means in this case we are going to say 2, or we are going to say log. Now we're saying 2 is the base, I'm going to put it as the base. 32 is the answer, so I'm going to say 32. What is the logarithm? The logarithm was 5. So basically this is how you can write a log. So if they say log 32 is equals to 5. Okay, 5 is the logarithm. So another example that we can put is, let's say they've asked you to write let's say they've asked you to write 5 to the power 4 is equals to 625. To write it as a log. Okay, so write your log. What is your base? Your base is 5, so it is 5. What is your answer? It's 625. Okay, what is it giving us? We're saying the power is the logarithm, that is 4. Okay, basically that. Now how do these things come about? There are rules to also logarithms. Okay, some of the rules of logarithms is that if I've got the log of a, the log of 1 actually, let's say I've got log, then there's a base, the log of 1 is always 0. Then if I've got the log, there's a base, and the log, the base and the number that we are solving for, or the log, I meant to say the base of the log and the answer are the same, then it means the answer will always be 1. Okay, so basically those simple basics, rules on logarithms are very, very important for us to know. Let's say we're asked to find the log of, let's say I've got the log of 81, then let's say this is 3. So how can I solve this one? Okay, so another property of logs that I haven't talked about is, if I've got a log, then let's say there's a here, there's maybe a, then this a is raised to a power something, let's say b. What is going to happen is that this b is going to go back, it's going to become the coefficient of the whole log. So in this case I'm going to have b log a and a, and if you say log a and a, that just gives us a 1, so my answer is just going to be b. So, or you can also try to reach that form. Then there's another rule of logarithms of multiplication and division. So if I've got a log, let's say I've got the log of, let's say I've got x and y. So these x and y are multiplying, and we've got the same base. So what now I'm going to do is that I'm going to separate the log. It's going to be log, the base is a, then again I can get x. Because they are multiplying, I'm going to plus them. Okay, log a and y. This is another rule of logarithms. Then another rule of logarithms is the division law. Let's say I've got the log, there is a there, then I'm dividing instead of multiplying now this time around. So what I'm going to do now is, for these ones, I'm going to, because they are dividing, I'm going to subtract them. So I'm going to have log a x minus log of y, okay, as long as the base is the same. So basically these are the simple rules on logarithms, and you're supposed to know how you answer questions on each of the same rules. So let's solve some questions to just cement on that part of the topic. Let's say I've got log, there's 3, then there's 81. How do I solve this one? So make sure that you make your answers to be perfect squares, and we've been talking about perfect squares since we started. 9 is one that can give you 81. Okay, so in this case I'm going to say log 3, then I can say 9 to the power 9 to the power I can write it as 9 squared. Okay, however I can simplify it further to say log, okay, log 3, the 9 is the same as 3 squared, right? Because 3 squared gives us 9. So I can put 3 is squared, but now don't forget there's another square there. Okay, so I'm going to put the square like that. Therefore I'm going to have log 3, then 2 squared, 2 multiplied by 2, that is a 4. Okay, basically now we have this. Now the 4, the power can drop according to the rule of logs. So the 4 can drop. I'm going to have 4. It becomes the coefficient of the whole log. The base is still 3, and we have 3 there. Now we've said if you have this expression, it gives you a 1. Okay, therefore we just have 4 multiplied by a 1, which will give us a 4. So the log of 81 in base 3 just gives us a 4. That's what it means. So let's solve another example. Let's say I've got log Let's say the base is a. Let's say I have a to the power 2. How can I solve this one? So the 2 is going to drop. So I'm going to have 2 log a and a. 2 log a and a in this case just gives us a 1. Okay, so 2 multiplied by 1, that is a 2. So that is how we solve this one. What if you have a number with a point? How can you solve it? Let's say I've got log 4, then I've got 0.25. How can I solve such a one? So this 0.25, you know the number that can give you 0.25 is 1 over 4, right? Because if I divide 1 divided by 4, that will give me a 0. Then I put a 0 there. 4 into 10. 4 into 10, that gives us a 2. Then remainder 2. Then 4 into 20, that gives us a 5. Okay? So able to see that 1 over 4 is the one that gives us 0.25. Now, if it's the one that is able to give us a 0.25, how can you write it just as a normal number? Because every time I've got a 1, the 1 can become a negative. So it's the same as 4 to the power negative 1, right? So basically that I'm going to replace it there. So I'm going to have log 4. This will be 4 to the power negative 1. Then from there now, the power drops. Okay, when the power drops, I'm going to have negative 1. Then I have the log. Then there's 4 and 4. So in this case, I'm going to have negative 1 multiplied by log 4 and 4. We are saying this whole expression gives you a 1. So negative 1 multiplied by 1, that is just a negative 1. So this whole expression gives us a negative 1. So this gives us a negative 1. Okay, so basically that's how we solve this question. Let's solve a few more questions, then we'll be done with logs. Let's say I've got let's say I've got what can we solve? Let's say I've got log, I've got a, the base is a, I've got x to the power 3, I've got y, I've got z, then it's squared. How can I solve such a one? So because these ones are multiplying, what do? You're going to separate them. So I'm going to have log, there is a here, I'm going to have x to the power 3, then plus log, the base is a, there is y, plus I'm going to have log, the base is a, z to the power 2 actually. Okay, then if you have that, now you just need to now solve. You just don't keep your powers like that, so your powers have to drop like that. Okay, they have to become coefficients. So I'm going to have 3 log of x, then there's the base is a, plus this one is going to be maintained log a, then there's y, plus we have a power of 2 there, it's going to drop, so I'm going to have 2 log, the base is a and z. So basically that's how you solve this kind of a log. Okay, so for logarithms, pretty much per se, they are not as complicated. Let's say you have log, let's say this time around you're dividing. Let's say I'm dividing x over, let me say, a squared. Okay, so how am I going to solve this one? So we said whenever you're dividing, you subtract the logs. So I'm going to have log a x minus log, the base is a, in this case it will be a to the power 2. Okay, just the way it is, a squared. So now what do we now do? Okay, I'm going to maintain the first one, log x. When I come to the other one, because it has a power, the power is going to drop. So I'm going to have minus 2, in this case minus 2 Then I'm going to have log A and A. Okay, now when I solve this, what do I have? I'm going to have log x minus 2, because this whole expression will give me a 1, so I can just end it there. So that's how you solve this part of logs. The last part of logs is for you to be able to solve equations and changing the bases. So how do you solve equations? Let's say I've got 3 to the power x is equals to 20. This is an exponential. So because you can't change the base to be the same on either side, okay, a good example that I can solve maybe for this one is let's say I've got 2 to the power x is equals to 4. So the way I'm going to solve this exponential to find the value of x is I'm going to make sure that they have the same base. So 2 to the power x is equals to 2 squared. Now the x and the 2 and the 2 can divide because the base is the same. Then the x will just be equals to 2. That's a simplified way of which I can solve. Now what if now I can't have the same base? 3x to the power 20. That's where now I introduce the log, because I can't solve it because I can't they don't have a common base. Okay, so I'm going to have log, let's say we pick base 10, then 3 to the power x. Okay, then this will be equals to log 10 on both sides, actually 20, like that. Now based on our rule of logs, the x is going to drop, right, because it's a power, so it will be x log, then we've got a 3. This will be equals to the 20 is also no, the 20 is not a power actually, so I'm going to have log of 20. Okay, then for me to remain with my x, since I'm finding the value of x, I'm going to divide with this on both sides. Okay, so this is going to cancel, so this will be the value of x. Now you can find what log 20 in base 10 is and log 3 in base 10 is, then you divide. Basically I don't have a calculator, then yeah, you're going to find your final answer. So basically that's how you solve equations when you're given, you know, such kind of questions to solve. Then the last part is you to be able to change a base. So let's say I've got a log a, the base is a and x. So this is very simple to change. Let's say we're changing this to base b. Okay, so if we're changing this to base b and it has only the base as a, just get the log of x and the log of a, then put the bases that you're changing to. So I'm going to have log x over log a. Then to which base are we changing to? If it's b, just put b and b. That's how you convert, you know, one log from one to another. So for example, I can have log, let's say the base is 2, then let's say this is 6. So how can I change it to base? Let's say I want to change it to base 3. If I'm changing it to base 3, I'm going to say log 6 divided by log 2. Since I'm changing to base 3, I'm going to put 3 there and 3 there as the bases. So basically that's how you change one log from one base to another. So basically this is the whole concept about algebra. You're able to see that we've solved from simplifying, building from all the concepts until to logarithms. So basically that's how it flows. You simplify first, then you build to other concepts. So and they were intermingling, factorizing, expanding until we reach to all these other concepts. So thank you, and we're going to see you in other sessions.